Today in this video you will learn different processes on gases. So let's start from isochoric process. Isochoric process is the process in which volume remains constant, and when a substance or gas is heated, its temperature will rise as well as pressure. Okay, so isochoric process is the process in which volume remains constant, and when a gas is heated, its temperature will rise as well as pressure. Now, isobaric process is the process in which pressure remains constant, and when a gas is heated, its temperature will rise as well as volume. The third process is isothermal process. Isothermal process is a process in which temperature remains constant of any working substance which is to be heated. So temperature will remain constant. And as we know that equation, the expression of isothermal process is PV is equals to constant. Here in isochoric, volume will be constant, and here in isobaric, pressure will be constant. Now, what is hyperbolic process? Hyperbolic process is the form of isothermal process. Okay, is a mathematical form of hyperbolic process. Um, According to hyperbolic process, if temperature of a if temperature remains constant of a substance, then its pressure, then its product of pressure and volume will be always constant. So this is hyperbolic process. Okay, as I said, this is a form of isothermal process. Okay, now adiabatic process. Adiabatic process is the process which does not involve heat transfer, but other energy and mass can transfer to it. Okay, so in this process, heat transfer will be zero, and mass will also transfer in this process as well as other energy. Okay, now isentropic process. Isentropic process is also the form of uh, adiabatic process. Okay, so it says the reversible adiabatic process is called isentropic process. Okay, so when the adiabatic process will be reversible, then it is known as isentropic process, as entropy will be constant in this process. The process in which entropy will remain constant, that will be our isentropic process. Now, polytropic process. Polytropic process describe all the other process. We will see later in the end of the video. So the expression for polytropic process will be PV to the power n is equals to constant. And we know the expression for adiabatic is PV to the power gamma is equals to C. So we are going to make the PV and TS diagram for all the process. So see here how to plot all the PV and TS diagram for all processes. First, for isochoric process. So PV diagram for isochoric process will be shown by simple line. As you can see here, volume will be constant, so it will be shown by simple line. Okay, volume will be remain constant, means V2 minus V1 is equals to 0, because V1 is equals to V2 is equals to V. In TS diagram, uh, there is no volume in both the axis, x-axis as well as y-axis. So we will make it by simple curve. Okay. Now for isobaric process, same. PV diagram will be, I have my pressure along y-axis, so the isobaric process will be shown by a straight horizontal line in PV diagram. and TS diagram, it will be shown by simple curve. Okay. Now the third process is isothermal process. For isothermal process, the PV diagram will be formed like a curve, and here in TS diagram, for isothermal, temperature is constant, and that temperature I have along my y-axis, so it will be shown by simple line in this process 1 to 2. Now the last process is adiabatic process, in which you may say the isentropic process, in which the entropy will remain constant. So see here PV. So PV diagram. Here I don't have entropy in along my x or y axis, so it will be shown by simple curve. And here in TS curve I have my entropy along x axis, so it will be shown by simple line 1 to 2. So this is the PV and TS diagram for all the process. First is for isochoric, then isobaric, and then isothermal, and the last one is for adiabatic process.